Hello everyone, welcome to my YouTube channel, and I am going to create a series of video on my channel on the topic Arduino. So let's get started. So what is Arduino actually? Arduino, as you can see, I have written the definition here. Arduino is an open source hardware and software company, project and user community that design and manufacture single board microcontrollers and microcontroller kits for building digital devices. So that this device that you are seeing on the screen, this is Arduino. So what is this? It is having a microcontroller here, and this microcontroller is the, you can say, heart of the this Arduino. So what this Arduino does with this microcontroller to make a task done. So we can use we can use a microcontroller without this board. If we just eject this from, and you can, if you wish, then you can use a microcontroller, just something look like this. It is having structure something like this. I'm not drawn the exact number of pins, so there is some cut design to indicate the numbering. Okay, so this is a microcontroller. Okay, so you have we have heard about two terms actually. One is microcontroller and one is microprocessor. So uh, just I'm explaining the difference between these two. Microprocessor in a brief, very processor and controller. Okay, so for doing computational tasks like addition, multiplication and all those things, we need a processing unit, that is CPU. Okay, so we need a CPU in both the ideas. Okay, and for executing a task or instruction, we have to store the instruction in somewhere. So we need storing devices like RAM, okay, ROM, cache memories and same for this RAM, ROM. Okay, so we have to store instruction in these storing devices, and it also have cache memory. So if we want to execute some instruction, for example a equals to b plus c, we have to give the instruction to CPU, but we have to store the instruction first, and after execution we have to get the result on the on some locations. Okay, so there are two ideas of designing the system. One idea is that that is followed in the microcontroller, that on a single chip we are going to embed all these three things: CPU, RAM, ROM. Okay, on a single chip, and some more components as well. But in the microprocessor we are going to use a main board, and this board, it is not the part of the CPU, RAM and ROM. It is a different mm, it is different thing. But this board actually typically called motherboard in our computer, and this connects the CPU with the RAM, with the RAM, and RAM with the ROM and all those things. Okay, and bus and control memory bus and all those things it is having. But in case of microcontroller, we are going to have all those components in us on a single chip. So these are the two different ideas. So so what Arduino has, it has a microcontroller. But now I think I have explained the difference between microcontroller and the processor. So coming to the topic Arduino, so Arduino helps us develop the project very fast. If we use a microcontroller directly, then it will become a bit tough for us to develop our project. For example, they this microcontroller is called AVR. Actually, AVR. As you can see, I have written the definition. AVR is a family of microcontrollers developed since 1996 by Atmel, okay, and acquired by Microchip Technologies in 2016. In Arduino Uno, it is 328P and sometimes PU also. There are some power consumption and minute difference between 328P and PU. So these are modified hardware architecture, and it is a 8-bit microcontroller. So you don't have to understand these things for working with Arduino, and this is the most amazing thing. You don't have to go deep in the technical things for working in and developing projects using Arduino. So for example, there are some advantage of AVR over Arduino. There is no bootloader. Execution is fast since bootloader is slow. So bootloader is something that I'm going to discuss in the video later on. And we need a microcontroller first, and a breadboard, and a program breadboard for example, I am going to blink an LED. Then what I have to do for in case of Arduino, I have to just connect this pin number to an LED, okay. uh, to an LED I have to just connect, and just ground in there. Here is a ground pin, and here is the positive and negative, and just write a program to blink this LED. So in case of Arduino, we can use jumper wires, because these pins are very properly settled and for using. But in case of microcontroller, we need some extra and a board for connecting. Breadboard is a board that actually helps to make a temporary circuit, okay. So we need these kinds of boards, okay, and fix the controller on the board, and some necessary components that requires to run the board. For example, this crystal oscillator, okay, some capacitors for has to be attached with the crystal oscillators to work properly. So these are the some things we need: a breadboard, microcontrollers, and programmer required. If you are using an microcontroller only, what you have to do, there is a thing called programmer. It is a device actually, okay. We have to take out this and plug it in the programmer, and then or you can just connect it with some wires. It's up to you. And then the programmer is connected to the laptop or any personal computer, okay, laptop or any personal computer, and the code is in the code is delivered to the microcontroller via programmer. So it is the thing that we require. But in case of Arduino, what we have to do, we just have to connect a wire. This is the wire actually, you can see this is the wire. We just have to connect it here, and then plug it in our laptop directly, and we don't have to just eject and program it and then test it again, and if it not works well, then again do the same process. So it become easy to upload, because we don't have to use the programmer. And one more thing is that we also have to write very efficient code, because the team or the organization Arduino make a easy method to write code and upload it. Obviously, I've told you, just you have to connect the Arduino with your laptop and just upload the code, and you don't have to have a separate programmer and all. And also you can write code very easily. For example, I'm going to try uh, I am going to explain you this code. This code does the same as this code, but this code is bit tricky and requires some domain knowledge about what is a microcontroller, how it works, and about the some RAM and ROM, and some port manipulation, bit manipulation, and all those things you need to know if you are going to write the code in this format. This is a C language .c file, and this is INO file. Obviously both of them are at first compiled, means converted to a machine level language that your Arduino microcontroller understand. Okay, machine level language that your microcontroller understand of, and with the same with this, it is at first compiled, okay, and then delivered to your machine level language, because this language is language that we understand. So I'm going to start explaining this. This is you can see pin mode 2. So what we are what we are doing here, we are setting pin number 2 as an output, okay, and in this case digital write is nothing but we are going to write a digital signal. There are two types of signal, digital and analog. I will be explaining all these things in much detailed in the upcoming videos. So in this digital write 2, and this is high, it you can just understand that the pin number 2, actually these are the number of pins, okay, from 0 to 13 here. So what I am going to do is pin number, I am going to put high voltage on pin number 2, and then wait for 1000 millisecond, it means 1 second, and then again digital write to with a low voltage, or you can say 0 or 1, okay. So and again wait for 1 seconds. So what it will do, it will blink, and with a delay of 1 second, okay. And also this does the same thing, but just try to understand what we are writing here. It is a hash defined FCPU, okay. This is 1600 megahertz. So you can see this device is called crystal oscillator, okay. uh, the speed that we use, uh, it, it it has different speeds. It is of 16 megahertz, okay. Okay, and we have to specify the speed that we are going to use, okay. Maybe I have told you 1600, not, it is not 1600, it is 16 megahertz, okay, megahertz. And then we have to include the libraries, okay. This required some programming language of C language, okay. And it is a some utilities, uh, and then what we have to do, we have to do port manipulation, okay. It is data direction bit, so we have to set these things, and this B specifies that we are going to use uh, port number B, and this code, and you can see this code is actually same, but in different languages these are. So for understanding this, you need a domain knowledge, like what byte is, what is a bit is, okay, what a 8-bit register, and all those things you need to understand these things. And this is ORing, or equals, okay. So we need to understand all those things, like what is OR gate, XOR, and okay. We have to understand these kind of thing for understanding this code and even writing, because just understanding is not required. You have to write codes on your own. So then you can see a while loop. It is also a loop. It's a looping structure in one, means the loop is going to run forever, okay. Uh, Sometimes we put a condition so that loop runs for some times and then stop. So in the same port that we have set for the output, what we are going to do, we are going to just turn on a bit. Okay, it is going to do the same task like this, but in a different way. And then we are going to delay, and then again turning off the bit. Okay, so it required the domain knowledge, like what a bit is. It is actually 8 bit. 1 2 3 4 5 6 7 8. So what we are going to do, we are just changing it from 0 to 1 and 1 to 0, and all those things we have to do. Okay, we need how mm, to or these things, and bitwise ORing and bitwise, and okay, bitwise or bitwise, and all these things we have to know to understand this code. So with Arduino these things becomes easy. So for the beginning and the initial time, I prefer this to start with. Even I started with Arduino in the initial time, and then you can shift to this thing, because in the industry level or the practical use, this is a bit faster. I'm going to tell you why a bit faster this thing is a bit faster. So for understanding one more difference, that is a bootloader. Okay, there is a bootloader, hence no hardware programmer is required. Okay, so what a bootloader is, just try to understand it. It is an IC, okay, integrated chip, okay, or circuit, you can say integrated circuit actually, and this is also an IC. So, and there is a laptop. Okay, I'm drawing a just a laptop. Okay, and it is a programmer. Okay, so when I am going to give some instruction to the system, what I'm doing actually, I am sending the instruction to the microcontroller via programmer, and programmer puts the instruction in the correct location. For example, ROM. Okay, from where in the runtime the instruction is transferred to the RAM, and then cache memory, and then executed, and all those things works. Okay, so what happens, I'm going to store it in the ROM with the help of this programmer. Okay, but the in case of bootloader, what happens, we we store a program. Okay, we store a program in the, for example, this is the total space for storing the complete program. And what we have done, we have just assigned a space assigned a space for a program that is going to stay here forever. Okay, a program that is going to stay here forever. And when we power on, okay, when we power on, in this case, when we power on, if it has some instruction, then it starts to execute. But in and if it has no instruction, then it is like it is paused. Okay, but in this case, when we power on, there is a instruction here. Okay, it starts a serial communication actually. Okay, serial communication. There are some types of communication that we can do in the microcontroller. I will be covering these communication in the further videos. So it start a serial communication, and it requires a additional hardware, and this hardware is this. You can see this hardware, it requires this. I'm going to change the color actually. Okay, you can see this black chip. Okay, it is actually a UAR to serial communication. It provides the interface to communicate with laptop and laptop USB and the microcontroller because it starts a serial communication, and we need something to communicate and mm, between our laptop and this microcontroller. Okay, laptop. So you can see mm, the serial communication is connected with the laptop via this hardware. So when this program finds that there is a serial communication established with the laptop, what it does, it starts reading the uh, and it starts reading the instruction from the laptop, and when laptop sends the instruction to the laptop sends the instruction, and obviously machine level code, not the exact code that we have written. It is first compiled and then converted to a machine level code, and that is sent to this. So this program, when it has nothing to read, then what it does, if it has an stored instruction, if it has an instruction, then it starts executing from this point. Okay, it start executing. But if it is blank, or if it is already executing, but the new task arrived, then what it does, it reads from the laptop and then write in the memory. Okay, then write in the memory. Then what happen when next time, when next time power is on, and when the complete instruction set is arrived in the microcontroller's memory, then when it starts, it directly start reading from here, and execution is started. So with this thing, we can solve the problem of adding an additional programmer. But there is a some minute problem. This program also holds some space. Okay, and it is near about 2K. It requires this space, and it stays here forever. And what is the task of this code or the program? You can understand it like that. After initialization, or the after power on, what is it's checked, if if some instruction is coming from the PC or laptop, it takes those instruction and place it inside its memory for further execution. Okay, and also set the program counter. You can say in more depth, you can say these things actually. But don't bother about these things, because these things are not required in developing the project. I'm just explaining the topic and trying to explain a topic a bit. So what happened, it sets the program counter to the first location from the from where the program is going to start execution. So this takes some space, and in case of just in case of this, you are just storing instruction in the memory, and you have complete memory to store the new instruction. You are not reserving some space for a specific instruction that does a specific task, but in this case you are reserving this that does a specific task. And what is the task of it? It takes the code from your laptop and just paste it in the memory. So these are the thing that bootloader does. So this you can say are Atmel AVRs are amazing ICs. Okay, but they can a bit tricky and challenging to program. Obviously it is tricky and challenging. I have told you that you need to have a domain knowledge to understand these things. You need a special programmer and some programmer. Yes, it is a hardware, and some fancy hex files, and it is not very beginner friendly. Obviously you need a bit knowledge. After that you can begin with it. But in Arduino has largely done away with these issues. They put a hex file. uh, these files have actually instruction, on their AVR chips. What on their AVR chips they have put hex files that allows you to program the board over the serial communication. This is the serial or you can say serial port. It means all you need to program with Arduino a USB cable. Okay, this serial communication, okay, this unit start a serial communication, and this serial communication is further interfaced with the laptop USB, because it is going to connect with the laptop via USB port, and the USB port is not a serial port actually. So then the serial communication is um, established between the laptop and this via this bridge actually, you can say also, and laptop, and the program is uploaded to microcontroller port. So I hope I have uh, I hope you have liked these videos, and if you have any doubt in the topic, then please uh, write in the comment box. I will try to clear all those doubt, and I will be also continuing in the very deep, like what is input, output, analog, and I will try to summarize the series